This is the first lesson in the modern medicine scheme of learning. Now, with modern medicine, what it does become, it becomes a lot more scientific. But the key thing you must understand is you don't need to know about the science. You do need to know about how these ideas cause change in medical understanding. So very similar to the last units, we're going to look at the cause of disease, we're going to look at the treatment of disease, and then we're going to look at the prevention with a case study, which will entwine all three. So the first lesson today is focusing on the cause of disease in the years 1900 to present. And with this, we're going to be looking at genetics and also lifestyle factors. Now, we need to know what's going on in the 1900s. Now, by this time, we know about germs. Remember, in 1861, Louis Pasteur came up with the germ theory, while in 1878, he developed it with the germ theory of infection. And on top of this, you also had the work of Robert Koch, who was looking at the development of germs and how each germ linked to certain diseases, which allowed for more effective treatment. However, in this period, in the 1900s, we develop a lot more technological understanding, a lot more scientific understanding, which allows for a much faster pace of development with medicine. So this is the first task you can do. Now, cause of disease, medieval, Renaissance, or industrial. Now, the exam really does require you to understand which period fits. Now, you need to have an understanding, like, for example, God. Was God a cause of disease in medieval, Renaissance, or industrial? Well, that's going to be medieval and Renaissance, because remember, in the Great Plague, that people resorted back to God because in a time of crisis, they went back to old traditional beliefs. So just spend a couple of minutes putting the correct time period under each cause of disease, and then we'll start the lesson. Right, so the key thing is, what do we know by 1900? So what we need to understand is that, as I've mentioned, we become a lot more scientific in the 1900s, and there was much more of a focus on laboratory medicine, which means more people were working scientifically in the laboratory, examining samples. Now, the samples might be flesh or blood, and these range of samples were examined using X-rays and microscopes to see what's going on in the body. But there was a problem with the cause of disease. Now, we know that germs, or we knew by this time that germs cause disease. But by 1900, scientists were realizing that babies were being born with conditions which are being developed in the womb. So they need to have an understanding of why were babies getting sick if they weren't being if they weren't in line of the germs. And this is where the genetic DNA aspect comes into play. So we've got a range of key words that you need to understand for this unit. So first of all is a hereditary disease. Now, disease is a very strong word for this. It's probably best to say hereditary condition. And this is an illness or condition that can be passed on to children from parents, grandparents. It's something where the DNA might be there might be a chemical pathway that's affected. So Down syndrome, cancer such as breast cancer, heart disease, Alzheimer's, Parkinson's. DNA. Now DNA, I'm not going to try and pronounce the posh science word because that definitely can't be done. But DNA is the information that determines what we look like, our hair colour, our eye colour. And that again is passed from the genetic pool of our parents and might have some impact from our grandparents as well. Fundamental laws of inheritance is an idea that we'll look at in a minute. The idea that genes come in pairs and that one is inherited from each parent. Human Genome Project is something we'll talk about again in a minute, but it's a way of understanding, breaking apart the DNA to understand how it worked. This was in 1991. Haemophilia is a genetic disorder that can be passed from parent to child that stops blood from clotting. And a mastectomy is a preventative method to stop hereditary conditions such as breast cancer. It's where you have one or both of the breasts removed. And an example of this is Angelina Jolie, who is a celebrity. She had a double mastectomy to prevent her getting breast cancer because this was seen to be her genetic pathway, something that she could have got in the future. So what we've got here is a timeline of the genetic developments over time. And what we need to understand is that the first three are, or the first two are very much theory. Then we have a big development in the microscope, and then the rest is more application and more concrete theories that are proven. So you've got Mendel in 1900, who was a German scientist that said that genes came in pairs, one from each parent, and this was the fundamental laws of inheritance. However, he didn't have any scientific proof at this stage because microscopes weren't powerful enough to identify genetic pairs. So Mendel's theory was purely just that. It was an idea at this stage. Now, the next thing is Archibald Garrod. Archibald Garrod was an English doctor. In 1902, he said that hereditary diseases were caused by information that was missing in the body's chemical pathways. Again, this was a theory, but it was a way of trying to work out why hereditary conditions were caused. Both Mendel and Garrod were theories that would be able to be developed because of what happened in 1931. Now, in 1931, German physicist Ernst Ruska and an electrical engineer, Max Knoll, developed the electron microscope. Now, this microscope was a game changer in regards to scientific developments in looking at the cause of disease, because it could magnify 10 million times, which was vastly different to the optical microscope that could only magnify 2,000 times. This allowed previous ideas to be looked back over and proven. If you have a look in 1941, Beadle and Tatum, US scientists, went back to Archibald Garrod's idea and proved it because of the microscope. So it was proven that the hereditary conditions are caused by missing information in our chemical pathways. Now, to take this one step further, we needed to develop the concept of DNA modelling. And in 1951, Rosalind Franklin and Maurice Wilkins, who worked at King's College in London, created an image of DNA using X-rays. And Watson and Crick, these are the key individuals. They took it one step further by creating a model of this DNA. So if you look in your science class, you might have a model of DNA. This was created by Watson and Crick. Now, this is important because Watson and Crick made corrections based on the X-rays that Franklin and Wilkins did. And what Watson and Crick realized was that DNA was shaped as a double helix, which could unzip itself to make copies. So our DNA was much more vast than we thought, which means there could be different chemical pathways, and these could still be in the unzipped copies of our DNA. This was a really key turning point, as it allowed us to begin to understand why people were getting ill. Now, the only thing with this is, it allows us to identify the cause of disease, but it doesn't really allow us any treatment at this stage. Now, the work on DNA continued up until 1900, when Watson and a team of 18 scientists started the Human Genome Project. And it was originally led by Watson, and what they were trying to do was decode and map out the human genome, work out what it did. By decoding it, it was going to hopefully allow more treatment, but we're still quite a way off that. We don't know what causes certain things, such as Alzheimer's, so there can't be a cure. And by the year 2000, this genome project, the first draft after 10 years. Now, the key thing with this is we are now starting to identify the cause based on the different chemical pathways of genetic understanding. It is difficult, but it's a concept that is really important. And there are some key players. So you need to have an understanding of how it developed, but why it was so important. So how does science help genetics? So I want you to finish the following sentence. DNA is a big turning point to help with the cause of disease because. I'm going to give you some help. Better understanding of DNA allows doctors to recognize genetic disorders, such as Huntington's and Down syndrome. It could eventually lead to a treatment, but not quite yet. Doctors can understand what causes these conditions, but they have not got the scientific advancement to further develop this yet. Some chemotherapy treatments, so if you have cancer and you have chemotherapy, some chemotherapy can use your DNA to see what could possibly help based on other people's DNA. And this is known as pharmacogenomics. So science does significantly help genetic understanding, Now, just as a task, by using the information that we've just looked at, pause the video here and answer the following sentences. They are very clear. It's just to give you that comprehensive understanding of the development of genetics. And if you want to take it one step further, write a paragraph on how genetics helped with the cause of disease in this period. Now, moving away from genetic disorders and genetic understanding, the next reason why people are getting ill in the modern period is because our lifestyles have changed. People have more access to more things than they ever have done before. And this leads to conditions. So development of the cause of disease is beginning to be linked to our lifestyle choices. And this in turn is allowing the government to look at prevention with our lifestyle choices, which could cause problems. So for example, the government have anti-smoking adverts campaigns, they have anti-drinking campaigns, but they wouldn't know this unless they made that correlation between lifestyle and illness. So one lifestyle choice that causes issues is drinking. Now, drinking over a long period of time or too much in one go regularly, known as binge drinking, can lead to kidney and liver problems. It can also lower the immune system, making you susceptible to other types of illness, which could cause problems with your organs, could cause problems with everyday life. Smoking is also another big one, which we'll look at in a lot more detail when we do the lesson on lung cancer. Now, smoking was a very popular lifestyle choice in the 20s, but by the 50s, the doctors started to make links between smoking and also looking at the number of men who were getting lung cancer, which led to changes. Doctors begin to notice that smoking links to a range of conditions, including heart disease, gum disease, tooth decay, while also secondhand smoke can also cause big problems to the people around them. And also, there are cases where lung cancer has been, someone has got lung cancer and they've never smoked before, but they have lived with smokers. Tanning, both naturally, so in the sun regularly without too much sun cream, or sunbeds can also cause skin cancer. Unprotected sex can lead to a spread of certain conditions or the spread of sexually transmitted infections. Drug taking can also lead to addiction and impact of the organs. Poverty. Now, poverty is a difficult one because it's not a lifestyle choice, but it's a lifestyle factor which can lead to problems, including dietary issues, mental health issues, while also it could lead to other lifestyle choices occurring. So it could lead to a high level of drinking, smoking, could lead to drug taking. So there are links with poverty and lifestyle choices. And diet. Now, ever since this course began in 1250, the four humors said that you got sick because of what you ate. This is one idea that continues today. Not the four humors, but the fact that what you eat has a massive impact on your health. Now, in today's society, two substances in particular have a huge impact on your health, and that's sugar and fat. Too much fat in your food can lead to heart disease, and too much sugar can lead to diabetes. This in turn, the reason why this is important is because people are starting to link the way we live to the cause of disease, which is really important. And it leads to more understanding, which in turn is going to help treatment and prevention. Now, on top of this, we also have new methods of diagnosis. Now, it's really difficult what needs to be understood is that we have a much more focused society, which also has more technological understanding, and diagnostics help us understand the cause of disease more. So you've got a range here. So you've got blood pressure monitoring, help us diagnose high and low blood pressure. This is going to help, especially to the development of treating and preventing. So if someone has high blood pressure, they can be treated through medication. By identifying the cause of blood pressure, it's important. Blood tests. Whenever you go to a hospital, the chances they'll do a blood test as a precaution. That tests for conditions which which without cutting the patient open, blood can show a lot, and it really can help identifying it within blood samples, looking at your cell counts, and this can really benefit looking at the cause of disease. Blood sugar monitoring allows people who suffer from diabetes to check their blood sugar level, which they can manage. So they can, for example, if someone who's diabetic notices their blood sugar level is quite low, then it might get to a point where they might have to eat something sugary to help them balance that out. X-rays help see inside the human body without cutting it open. Now, X-rays definitely developed significantly from the 1890s, and today they give off much less radiation, whereas before they could burn the skin. But the key thing is you can diagnose things such as broken bones, which allows a treatment, allows a cast to be put on, which helps the patient in general. MRI and CT scans are ones that people mix up quite a lot. Now, MRI scans use magnets and radio waves to create an internal image of the body. They're more in depth and can identify soft tissue injuries, which things like X-rays can't do. And a CT scan is more advanced. They diagnose tumours and other growths in the body. So if you ever watch these programs, you ever watch medical programs, they might say, go to CT, and it's that great big machine which people will go through. You won't see the doctor in there with you because of the radiation. It's not damaging, but it's still radiation. If a doctor gets too much radiation, it could cause problems in the future. Ultrasounds, which are also known as sonograms, use sound waves to build up a picture from inside the body. Now, ultrasounds can be used for pregnancy to look at conditions of the baby. They can also diagnose kidney stones and gallstones. So they can look at things without, and they put that gelatin on your belly and then they look inside. They look at what's going on there. They build a picture. And they also use sound waves to see if there's heartbeats with babies. ECGs are used to track your heart activity. That's where they put the stickers on parts of your body, and they can print out a heart tracker to see what your heart is doing. This in turn will allow to identify murmurs or any issues with your heart. And an endoscope is usually for digestive problems. So if you've got problems with your stomach that doctors can't see in the scans, then they will put a small camera on the end of a thin flexible tube, put it down your throat to investigate what's going on in the digestive system. This can also help with treatment. And there's an exam practice question here. 4-mark, explain the difference. Explain one difference in the idea of the cause of disease in the years 1700 to 1900 compared to the years 1900 to present. So basically what this question is asking you is, what did people think was the cause of disease in the industrial period? And then, well, how did that change in the modern period? Remember, you need to give a piece of evidence, explain it, compare it, evidence, explain. If you want to write it, there's a few hints here. 1700 to 1900, germs, spontaneous generation, miasma, and the focus on Jon Snow. And then using this lesson, do the last part. There's a lot of information in this, and you might want to go through and make some notes. Modern is definitely one of the most difficult ones, so watch this a couple of times, and it will really help you with your understanding of modern medicine, and especially the cause of disease.